So hey guys, in previous lessons we discussed different separation techniques that can be used to separate the components of mixtures. Now these separation techniques are important because most substances do not exist in their pure forms. Most times substances contain impurities which make them impure, and these impurities must be removed to improve their levels of purity. For example, when grains of beans are harvested from a farm, they contain chaff as impurity. Now, one would definitely have to remove this chaff either by sieving or hand picking because it makes the beans unfit for consumption. Purity is a very important criterion in many chemical industries. For example, if a drug contains impurities, it may cause harm when ingested. So the chemicals used for the industrial production of drugs need to be produced at a high level of purity. As a matter of fact, substances are usually more efficient and safe when they are pure. Now, the question is, how do we test for the purity of a substance? Well, there are different methods that can be used to test for purity. We can carry out a simple comparison of the substance with its pure sample. We can also make use of more advanced or sophisticated methods. In general, the physical properties of a substance like melting point, boiling point, and density can be used to confirm purity. These physical properties can be used because pure substances have specific melting points, boiling points, and density. So if there is any impurity present in the substance, these physical properties will be altered. Now, let's see how to determine the purity of this naphthalene sample by measuring its melting points. Bear in mind that pure naphthalene melts at 80 degrees Celsius. The materials needed for this experiment are a boiling tube, retort stand and clamp, tripod stand, wire gauze, thermometer, and a Bunsen burner. We will start by placing the naphthalene sample in the boiling tube. Then we place the boiling tube in a water bath and apply heat using the Bunsen burner. On heating, naphthalene melts, and we insert a thermometer into the molten naphthalene and check the readings. The reading on the thermometer should be above 80 degrees Celsius because the temperature of the flame was not monitored. Next, we turn off the flame and check the reading on the thermometer. On doing this, you will notice that the temperature at which naphthalene solidifies is 80 degrees Celsius. The reading on the thermometer remains at 80 degrees Celsius for a few seconds, after which it begins to drop on complete solidification. To confirm the melting point of this sample, let's warm it again and read the temperature at which it melts. As displayed here, we can see that the sample melts at 80 degrees Celsius. And again, the temperature reading remains at 80 degrees Celsius for a few seconds. Note that this is because temperature is always constant during state changes. Now, since the naphthalene sample melts at 80 degrees Celsius, it confirms that the sample is pure. Using a similar procedure, we can test for the purity of other substances. In a future lesson, we will discuss the effects of impurities on solids and liquids. In the meantime, let's summarize our takeaways from this lesson. Most substances do not exist in pure forms, and there is a need to test for purity. The physical properties of a substance like melting point, boiling point, and density can be used to establish its purity. Now, this is where we will draw the curtain for this lesson. I would love to see you in the next one.